Hey guys, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at the second video from Lesson 1, Chapter 5, which is talking about working with radicals, and more specifically, we're going to be looking at adding and subtracting radicals. So to add and subtract a radical, or radicals, the radicals must be what we call like radicals. So you can kind of think of it as like terms when, say, we're trying to add exponents or variables. So essentially, like radicals, will have the same index and the same radicand. So you can kind of think this, as I was saying, just like exponents and variables. So say we had x squared and 2x squared. These are considered like terms because they have the same variable and the same exponent. So say if we want to add these two together, we just add those coefficients, which we can assume that this one here is 1. So we go 1 plus 2 is 3, and then variable and the radicand stay the same. So we'd be left with 3x squared. So an example of, say, a like radicals would be, say, the square root of 7 and 2 times the square root of 7. Here they have the same index and the same radicand. So index here would be a 2, and then the radicand is a 7. So these here are considered like radicals, and then we could add them or subtract them if we wanted to. So an example of unlike radicals would maybe be, say, the square root of 7 and the cube root of 7. These are not like terms because they do not have the same index. So here we have the index of 2, here's an index of 3. Even though they have the same radicand, they do not have the same index, making them unlike terms. Another example, say the square root of 7 and the square root of 5. Although they have the same index, they do not have the same radicand, which makes them unlike terms. So one thing I am going to caution you when, say, you're working with radicals is just because the first appearance of two radicals, they might look different, but if they're not turned into the simplest mixed radical form, you might not actually be able to tell if they're like or not. So say, for example, we had the square root of 7 and the square root of 28. At first you would say, well, the radicands aren't the same, so therefore these aren't like terms. But one thing that we can do is, if this square root of 28 is not in simplest terms, because this can be written as 4 times 7, and 4 is a perfect number, meaning we can rewrite it outside of that radicand, or outside of that radical symbol. So you take the square root of 4, which is 2, and then all you're left with in that radical is 7. So here you have 7 and 2 root of 7, making them like terms. So please just take a little bit of caution when trying to determine if two radicals are like or unlike. So suppose now we have some like radicands or radicals. Then what we have to do is we just add and subtract the radicals. And in order to do that, you simply just add the numbers that are outside of the radical. So say, for example, we had the square root of 7 plus the 2 times the square root of 7. You add the numbers outside of your square root symbol. So here, if there's nothing there, you can assume it's a 1. So you go 1 plus 2 is equal to 3, and then your square root and that 7 stays the same. So your radical symbol and the square root stays the same. So it's actually very similar to adding variables and exponents. So here we had 1x squared plus 2x squared. So you added the coefficients and left the variable and that exponent the same. So same kind of idea here when we're adding and subtracting those radicals. So now we're going to do an example from your notes, and this here is example number 2 from your notes. So in this example here, we're going to add and subtract the following radicals. So here we have negative square root of 27 plus 3 square root of 5 minus square root of 80 minus 2 square root of 12. Now at first glance, none of these radicals are like terms. Here we have 27 in our radicand, we have 5, 80, and 12. None of those are like terms or like radicals. So at first glance, we can't do anything. But as I cautioned you earlier, you have to make sure that this is in simplest terms, meaning we have to rewrite each of these radicals in mixed form. So we're going to start off with this negative square root of 27. So when you're trying to convert to mixed form, you want to ask yourself, well, can I rewrite this number, so 27, as the product of a perfect square and some other number? So here we can rewrite 27 as 9 times 3, and 9 here is a perfect square, meaning we can pull it outside of those outside of the square root symbol. So when you pull it outside of that square root symbol, you need to square root 9. So you have the negative square root of 9 is 3, and then you're left with the 3 inside your square root symbol. Then we have the 3 root of 5. So 3 square root of 5. That is actually in simplest terms already, because 5 is a prime number. It is not perfect, meaning we can't square root that number. So this one here is actually all good to go. Then we can look at this negative 80. So if you want to try and think, well, what two numbers can multiply where one of those numbers are perfect? And in that case here, we can rewrite the square root of 80 as 16 times 5. One thing that's important is that say if you guys are ever unsure of whether or not you can break down a number, you can always write down the factors. So you could write down 80 over here and then write down its multiples. Its factors. So you'd write 1 times 80, 2 times 40. 3 can't go into 80, so you move up to 4. So it'd be 4 times 20, and so on and so on. So you get to 5 and 16, so on and so forth. And then what you want to do is you want to try and find, well, which one of these are perfect squares? And in this case here, our 16 is perfect. So we're going to rewrite it as 16 times 5. So we can pull this 16 on out. And I guess I won't forget this one here is a negative square root of 80. So the square root of 16 is 4, so we can write negative 4 square root of 5. Then we can look at our next radical there, which is negative 2 square root of 12. You might be tempted to think that this one here is already in mixed radical form or in simplest terms, but look at this 12 here. This one here can be rewritten as 4 times 3, and 4 is a perfect square. So you can go ahead and simplify this. So we can rewrite this as 4 times 3 and pull out that 4. One thing that's really important is that when you pull it out, because there's a number here, we have to multiply those two numbers. So we take the square root of 4, which is 2. So we go negative 2 times 2 is negative 4, and we get the square root of 3. Then we can write this all combined. So we'd have our first number here was negative 3 square root of 3. Then we added 3 square root of 5. Then we subtracted 4 square root of 5. And then we subtracted 4 square root of 3. So now that we're in simplest terms, now we can look at finding like terms. So here you might want to start with the first number here. So we have 3 square root of 3. So you want to find a number that has the same index and the same radicand. So you want to look for something that has the square root of 3, which is our last term here. So we'd have negative 3 square root of 3, subtract 4 square root of 3. So what we do is we take our coefficients, or those whole numbers out in front of that radical, and we add or subtract them. So we're going to go negative 3 minus 4, which is negative 7. And then the radical doesn't change, so it stays square root of 3. Then we can look at our next set of like terms, which is 3 square root of 5 and negative 4 square root of 5. So you add or subtract those coefficients. We have 3 minus 4, which is negative 1, and leave the radical the same. Just to clean this up a little bit, we don't need this 1 in front of our radical, so we can rewrite this as -7 square root of 3 minus the square root of 5. -7 root 3 and -root 5, those are not like terms, so at this point here, you're all done your question. You have fully simplified this question as much as you can. So that is actually everything here for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.